Greetings once again, students. I certainly did not imagine I would be teaching the end of chapter 14 via video. Hopefully this is working for you better than just looking at the notes and hearing something is helping. I wanted to skip to this section on the notes I posted today. I want to talk about this, the absolute value on complex numbers. This is something I will ask you to do on the upcoming test. So again, absolute value of a complex number, just shorthand for z, where z is just representing some a plus bi number, right? So the real number part of that, that's the a squared. The imaginary part of that, the b squared. Add those together, square root it. That is going to be the absolute value of the complex number. So recall the Argon diagram here. So let's say we have some element z equals a plus bi, of course. But so if I ask you what is the absolute value of z in this case, well, based on the formula I just gave to you, right? It's going to be the square root of the real number part, which is, again, that's going to be the a, squared, and then plus the imaginary coefficient, the b part squared, okay? So let's say I have this, a plus bi. Let's say that this was, let's say it was negative 5 plus 3i in this case. So in this case, the b, the absolute value of b, well, it's the absolute value of 3, which of course is 3. And then, of course, the a is negative 5, but of course the absolute value of negative 5, of course, that's 5. So the absolute value of the number, of the z, is going to be and so if I'm writing this, negative 5 plus 3i, quantity squared, this is going to be the square root of 3 squared plus the negative 5 squared, and of course I almost don't need to write that. I know you know that that's going to be positive. This is going to equal the square root of 34. Got it? So if z equals negative 5 plus 3i, the absolute value of z is the square root of 34. Okay, hopefully you have that. Great. So we're going to use this with an equation solving method down here. So and here's the shorthand for this, of course, what I just talked about. The absolute value of z is the square root of a squared plus b squared. Okay. There's a little bit of work right here that they're showing with exercise 317 and such. But ultimately what we're about to show here is how we will find the square root of complex numbers. Okay, so again, we can talk through we talk through this a little more in class if I had 40 minutes to gab at you, but I'm not going to make you sit there and listen to me for 40 minutes. I just want to skip to the good stuff here. So let's jump ahead here to this. Let's go. There it is. Getting there. There we go. Square roots of complex numbers. So there's a couple of different rules involved here, and so this is the part that you've got to pay close attention to. If the imaginary part of the complex number in question, which will be the because if we say z squared is equal to w there like this, okay. So all right. Let's back up for 1 second. Again, this is saying the imaginary part, right? If w is greater than 0, then z, the solutions for z are going to be this whole expression. This is kind of a lot, right? But this is why I would ask you to just kind of skip ahead to this part and just take a quickie look at this. So what I'm trying to explain here on this is, let me go ahead and do one of the purple examples here. If I've got this, if I've got something where the imaginary portion is greater than 0, for instance, let's say I'm doing the square root of 3 plus 4i. Okay, the real number part, that's the 3, the imaginary part, that's the 4. They're both positive in this case. Got that? So when the imaginary portion is greater than 0, like this, the square root of 3 plus 4i is going to be defined as follows. I'm going to take the square root, and I'll take 1/2, just like the formula over here is calling for, right? And then it needs the absolute value of the w. So in this case, what was the absolute value of 3 plus 4i? What did I just show you, right? The absolute value of this is going to be, in this case, the square root of 3 squared plus 4 squared, which of course those add up to 25. Oh, this is just going to be 5. They want 1/2 of 5 right in here, understand? So that's going to be 5, okay? And then plus the real number portion, so that's 3, all right? So we got that. And then we'll have plus, and we'll say I, and then we have the square root of 1/2 of, again with that absolute value part, excuse me, absolute value part, which is still 5, okay? 1/2 of 5, let's close that up. And then it says minus the real number portion this time instead of plus. Okay, but wait, we're not done, because notice there were 2 answers here. We need the negative value of this. Well, what's the negative value? Well, the negative value is just it's the same darn thing again, isn't it? The square root of 1/2 of 5 plus 3. And then we'll have minus I times the square root of 1/2 of 5 minus 3. Whoops, there we go. 5 minus 3. Perfect. All right, and so, yeah, this will simply simplify. 1/2 of 5 plus 3, well, 5 plus 3 is 8. 1/2 of 8 is 4. Square root of 4 is 2 plus. And then I've got 5 minus 3, that's 2. 1/2 of 2 is 1. So square root of 1 is 1. So I have 2 plus I. And then this over here is going to wind up being negative 2 minus I. What do you think? Hope that made sense. So now if we have, let's go with, let's do this one over here. I'll do this one over here on this side of the notes. Let's say I had the square root of, let's say we're doing 7 minus 24i. And I chose minus 24i because now I've got something where the imaginary portion is less than 0. You understand? So now I got to use this whole formula. Yes, you would absolutely have this available to you on your notes when you're taking a test on this. It's a lot to try to memorize, especially here in May. But anyway, I'll just do 1/2 of, and now absolute value of this. Remember what I said about the absolute value? That's that a squared, plus b squared portion. In this case, 7 squared plus 24 squared square rooted. All that is going to, I'll save you the math, or of course, if you're sitting near the Pythagorean theorem poster, you can look up and see the triple. This is 25, and so the absolute value of this is going to be 25. Sure, so we have it. Okay, now so I've got 1/2 of, and it's 25 plus the real number part. The real number part was 7. Okay, fine, and okay. And then I've got minus, and this is I, and then that's an I. Square root of, again with the 1/2 of the absolute value, now it's 25 minus 7. Good. And then the negative part, you get the idea of this. Yeah, it's blah, blah, blah. I mean, it's going to be the same thing again, right? Yeah, of course. So I go to simplify. 1/2 of 32. What's half of 32? Of course, it's 16, so that's going to equal 4. And then I got minus, and then I've got I times 1/2 of, it looks like 18. 1/2 of 18 is 9. Square root of 9 is 3, so there it is. 4 minus 3i. And then the negative part, it's just going to be the opposite of that. So it's going to be negative 4 plus 3i. Okay? Hope that's not too bad. All right, and this will be about the point where I start asking, say, you got any questions? Anyway, this is, you kind of need this, though, with this, square root of a complex number, because you've got these complex numbers here. When you're doing quadratic formula, you're going to have to, if I have a discriminant that's, where it's something like 8 plus 6i, like this, it's like, oopsie. So, now I've got to take this, and I'm going to find that this is going to be 3 plus I when I take the square root of that value. Okay, so that's, and then So then, quadratic formulas, you can see the 3 plus I shows up here, here. So it's, negative b plus or minus, and yeah, square root of 8 plus 6i was, 3 plus I on this, okay? And it's plus or minus those amounts. And you get these solutions on this, complex quadratic equation. It's quite messy, yes. And so for that reason, on 318, I took the liberty of giving you part B because, this one, that's the more complex looking one, obviously. This is the answer key, straight up and down. Yeah, so although it does occur to me that this part here has got cut off, I should write minus 624i right there. There we go. And yeah, that's, yeah, there you go. When you go to, like I said, solve this, yeah, I mean, the solutions to the equation are right there. Hopefully this process of, finding the absolute value, and then you use that absolute value to find the square roots of complex numbers. All right, so hope that made sense to you. Gosh, I hope to get to see you guys again really soon. Thank you for listening. Be sure to subscribe to my YouTube channel and check out the links for merch. Okay, just kidding. I don't really have any merch linked. All right, have a good one.